to us about FSP. And before we get started, I wanted to say that this will be the last time that we have a meeting at 4 p.m. I'm actually going to move this later to 7 p.m. to try to get cover more, Eastern. So I will be moving this. I will be and we will still have the every other week or every other meeting will be in the AM.
Makes sense.
Okay, so that way it works out kind of like the Tiano core. So, but I'm not doing two of them in one day.
No, that's an amazing feat of bravery. Yeah, he's doing geo-friendly in one day. Yeah, I would recommend repeat that pattern.
Yes, and so I wanted to ask, does anybody have any opens?
So Mickey, for the they just had the OFs or the OCP session yesterday on FSP. Were they going to put up the slides for that, or is that where they're going to post the new? Oh,
you mean Amos Boo from Intel, who talked about the FSP SMM work?
Right.
I believe Archna from OCP said the slides should be up later this week on the Open Compute site, so it should be done. Yes.
So Mickey, I don't know if you want a pointer from, or if we should add that pointer to the USF site, since that's the latest future-looking draft version of the FSP spec, right?
Sure, I can do that. So when did I didn't even know about this OSC1.
Yeah, it's under Vincent. I'll send you the link. We just gotta go find it.
Thank you. Okay, if there's no other opens, I'm going to go ahead and let Vincent go ahead and get started.
Hey, thank you, Mickey. So, hi, Vincent Zimmer with Intel, and wanted to give an update on the Scalable FSP. So, what I actually did for this talk is I took our December USF presentation we did at OSFC and kind of edited out the non-FSP topics just to sort of reframe. I left the overview to sort of help frame where the Scalable FSP fits, but I was really going to just reprise some of this material very quickly in case folks, land for the first time at the USF site. They'll have this material, but again, everything in black is essentially a repeat from there. And then I added some new content regarding where we're going. And so if folks recall this first series of meetings in 2022, we've kind of been iterating through the USF stack. We've done some sessions on payload, the different bootloaders. We actually did one on configuration. And this is the one topic area that we hadn't closed. It's kind of the end of the public USF spec. So sort of treating today as kind of providing this compendium of overview and then refreshing the topic on input we've heard in 22, and then also wanted to tie off today's discussion with a kind of a timeline of what we'd like to do with the community in 2022 with respect to this material. So that's the agenda today. We're going to quick recap of what is USF. We're going to click quickly through the constituent elements of the FSP, and then where do we go forward together as a community. With that being said, and then I posted in the chat if folks are online at this variant of this talk, you can read ahead if you like. So the USF again is an initiative to scale how we produce firmware and provide modularity such that we can compose silicon enabling with different platform construction. And that's kind of a full stack architecture of which the bottom is encapsulated is sort of how Intel as one representative silicon vendor is composing all of its ingredients and then exposing that ensemble through something called an FSP. So today's topic is the scalable FSP, this bright line here, and then some of the other aspects of the stack we've talked earlier. I'm going to read in a bit on interactions with the FSP and then also how FSP impacts some of the different POL implementations. But that's kind of the framing of today. There's the full USF stack, and we're going to click into the FSP, which is the scalable FSP. And so if I speak too much ahead, I'll probably overrun the next 3 slides. So I'll probably just walk the narrative through the deck here. And again, this is important because this is how the various bootloaders or POLs, platform orchestration layers, interact with the silicon. So that's where it fits in the entire stack. So what is FSP? It's a binary file. There's a document on how to integrate it, and then there's configuration. So how to express various behaviors of it. And then there's also a rebasing tool today because where you put your FSP and your final ROM image have to fix it up based on its execution address. And again, it provides the silicon initialization, but since different SO systems on a chip can be composed differently on platforms, you might have to have different settings. And so that's where the YAML-based configuration comes into play. And then other variants of the different SOCs are encapsulated in a document called an integration guide. So there's, again, different components that get initialized into by the FSP, and it plugs into these different firmware frameworks or POLs. And the last public variant of the FSP spec is the 2.3 from last year. And we have an example where we took an Intel SoC and sort of built everything from scratch on top of the FSP for a specific SoC. So there's a white paper in there that might be of interest to go reach out to. So what you'll notice in this deck is I have a few links to various documents here. So kind of the history of this infrastructure again is we had the 1.0, which was at the time was kind of a combination of interfaces and the silicon details. And so we kind of took the generic interactive elements and put into an EAS and then segregated the other components into, again, the integration guide. We evolved the FSP based on community and customer feedback to the 1.1, and then 2.0 we faced a problem where the original FSPs were all about memory map execution out of this SPI NOR, and for platforms we had like Intel Apollo Lake, which were copied to SRAM by an SoC microcontroller. That assumption of being memory map kind of broke down. So that motivated finer grain decomposition of the FSP into these different volumes, different components, one to enable temporary memory, one to turn on DRAM, and one to sort of finalize your silicon initialization. And then again, this is kind of the binary layout. Each of these components has some configurable elements. Each has its own information header, and each exposes the a set of interfaces. So that's kind of the sort of the state of the art, the 2.3, where we're at today. And again, this is kind of review information, so I'll motor through it pretty quick here. But the actual binary structure again is fabricated like a with like a PI firmware volume, and has this firmware info header, which has these various pointers to these entry points or these interfaces that we showed earlier. And this kind of relates to the USF stack in the sense, again, of want to have this one green binary in the middle here, our Intel FSP, which is kind of invariant of any platform design. It really abstracts the SoC today, maybe an XPU tomorrow, but it's silicon specific, board independent. And so board variants and then the frameworks of which the platform code is written have these obligations. These are the steps it needs to go through, but it interacts through the FSP again through these well-known interfaces. So again, the FSP produces these interfaces, and then these interfaces are consumed by the various POL implementations, Core Boot, EDK2, Slim Boot. And so here's another view of, say, a UEFI style interface, a construction with an Intel FSP. So PI spec talks about SEC, PI, Dixie as those 3 phases. And so these are the points at which a EDK POL would be able to interact through the FSP, and in this case, API mode through the various phases. And so there's some public infrastructure code, these things we call the wrappers, the Intel FSP2 wrapper package that abstracts, that provides these interfaces. And the reason I bring this up is when we talk later about some of the things we can do in USF, we're going to talk about FSP, but FSP is sort of this sort of train that's sort of moving on its own. It has these fixed interfaces, but as we try to collaborate and share code and get efficiency across our different bootloaders, we fabricated, these packages for an EDK style POL. We'll talk a little later about Core Boot, Slim Boot have their own. These are opportunities to align the type of code in our POL that interact with the FSPs, and the USF spec would be a great place to evolve some of that, quote, shareable code, in addition to some other idiomatic code where we have capabilities that we sort of need to do on all our bootloaders, how we would share code, how we talk to an FSP is another opportunity. So that's kind of why on this slide, highlight those specific packages. Another facet of the FSP is it has another way to interact with it. With 2.1, we introduced something called dispatch mode. So up to 2.0, the FSP, the public interfaces were only constrained to the temp RAM, memory init, silicon init, and everything else was opaque. Well, it turns out at Intel, we've been building the FSP based on PI technology. And so it already had the PPIs in there. It's built as a firmware volume. So to ease integration with EDK style bootloaders, the dispatch mode was made it kind of documented that this FSP can be interacted with through that info header and finding those API call points through API mode, or just use some of the PPIs in dispatch mode. So this shows how that same FSP could be interoperated with. The green is again the bootloader, the OEM code, and it just turns out because we build today's FSPs with PI, you can interact with the PI core and modules inside through PPIs. And this is the dual of that flow that we had earlier with API mode, with dispatch mode. So today up to FSP 2.1, 2.2, and the latest published 2.3 support both API and dispatch mode. And again, we have the same containers, TM and S. They're the same FEs. They just now expose configuration through PCDs and PPIs as distinct from the API mode call points and UPDs. So, a lot of customer flexibility, a simple interface. You can drop your existing bootloaders, a richer EDK2 style code. It mostly just works. The challenge is, of course, now we have 2 ways to talk to the FSP. Right now, we have, actually, I should update this link here. We actually have all of the binaries now on GitHub, github.com/intel/FSP. So that's a bug. And on the GitHub site, you can actually find the instances of the FSP binaries and the integration and those integration guides I talked about. So while my browser is thinking hard about finding the internet, we'll go back to the PowerPoint here. Some of the things we've kind of been asked about: openness. One way we could be more open is the construction, how to build an FSP is actually public. So there's something called an Intel FSP to package, which is the infrastructure code we use to build an FSP, and that's open. And one of the things we did was leverage that openness to talk about potential futures of the FSP with something called an FSP SDK, which I'll talk a little bit about at the end. So that's kind of FSP sort of today. And here's a kind of a view of today from the web. So this is where, so github.com, Intel, FSP, if you go to the web, you can actually find directories for all many different Intel systems on a chip. Alder Lake, the Denverton servers, IoT, Elkhart Lake, Cabby Lake. And so maybe we can click into Tiger Lake here. And so what you'll find is that integration guide I mentioned, which will have details of how to use the FSP for that specific SoC. And then for the client, here is your firmware device, or the actual binary that has the FSP, TM and S, and then we have some sample include files. Since FSP has integrated graphics, the video BIOS table, for example. And so this is kind of how we put the FSPs on the web today. And again, some of the work here in USF has been to optimize using the FSP, how to configure it, and then we'll talk a little bit more about how we can evolve it. And one way to evolve it is authentication. So there's been a lot of concern in the supply chain about provenance of your firmware. Where do things come from? Do I have the latest? Is it serviced? And so since the FSP is a binary, it offers the opportunity to maybe provide some of that provenance tracking and marking. And so to that end, we've introduced something that the Trusted Computing Group has been working on for a while, called reference integrity manifests. And so, like if you get a package in the mail, it has a shipping label that says you should have this in the package, this, that, and that. Think of it as kind of your manifest of what you expect. And so as we apply this to the FSP, we can provide RIMs for our different FSP binaries. Give it a tag. How is it measured? What are the expected digests or hashes? And we published an FSP measurement and attestation document to talk about this. And we actually have some tools published on a branch, I think I'll talk about in a minute, to actually create these manifests. And the idea here is, as we have other binaries in a sort of a future ecosystem of these different stacks, creating again these manifests, and this is pretty timely topic. Harry mentioned at the top of the call, the Open Compute guys folks had a summit earlier this week, and one of their topics was on SBOM, software bills of material, right? Another way to express these manifests. At the same time, the UEFI forum had a chat on this. So this is kind of timely. And so the way we look at it here is as follows. We have these well-formed binary objects, but how do you know it's the expected ones? And so again, this is a way that the publishers, it can tell, as one example, as an FSP publisher, but you could apply this to other things in the future, like reusable payloads and other things, publish RIMs, so that folks can say, hey, do I have the latest one? And then, maybe you'll have some agent in the operating system that'll check these manifests, look at your BIOS, your host firmware. You can yellow bang or send alerts if you don't have the latest. That's kind of the intent behind this. So that's what the RIMs are. And then we've added added capability into some of the bootloaders. Here's an example of EDK2. I mentioned that kind of Intel FSP2 wrapper package. Again, this is generic code that lays on top of the well-defined FSP interfaces. So we have libraries here that can generate the measurements of the FSP pursuant to what the RIMs will be explicating, because the RIMs will declare this is what the measurement should be, but when you start a system, you need some active agency in the firmware to create the measurements. And again, this is an opportunity to say, hey, this one bootloader did it this way. Can we, share the interfaces and libraries across all our bootloaders? But this is just one example of one bootloader creating the configuration. I left the YAML in here, looks like, so maybe I'll just go quickly today since it kind of is coupled with the FSP topic. So again, the FSP is this nice abstraction with some APIs that the bootloaders call, but then there's a rich set of configuration, to tens to hundreds of different configurations, some build times, some post ship perhaps that you want to change that abstract how to use the FSP. And so this is where, again, this heterogeneous set of bootloaders expressing configuration, including FSP's historical one with BSF, moving to YAML, and then having kind of an open source tool for this. And so again, this is kind of relevant for that FSP presentation, because if you go back to our kind of example of an FSP today, here is the configurability of this Tiger Lake FSP. And so here's, all of these different configurations, quite a few. These are also described in the integration guide, and they're in this kind of non-standard encoding called BSF. And so YAML is a way to kind of normalize how we do FSP configuration. And again, as we talked in the earlier talks, opportunity to move even for the bootloader configuration. And so this config editor, all of these different FSPs that you saw are a way to configure them. So again, you have to write code in your bootloader to talk to FSP. The different bootloaders have different libraries, and then this is a common workflow to actually configure the FSP. And then this is just a reminder of how to get to the configuration editor. So that's kind of, maybe I'll pause here for any questions, because this kind of is where we're going to come to the end of what I discussed at the December kind of USF overview. And again, the platform POL and the payload we've talked in other sessions. And so this kind of ends kind of today's FSP, and then I was just going to talk a little bit about a couple of these future looking things. I think we've already talked about the unified configuration and authentication, but I was going to spend the next couple slides sort of speaking to a couple of the updates. And in fact, as questioned earlier, this SMM topic was actually presented at OCP a couple days ago. So probably in the minutes at some point we can back point to that one. I'm not going to go into too much detail, to be honest, but I wanted to at least say an FSP is going forward. What is the community sort of USF perspective on it? So I'll pause here for a sec, and if no questions, you can see my mighty fancy PowerPoint for today. So sort of the scalable FSP and USF. So what are we doing today? Where are we at today? So we have the USF specification itself. It has a lot of chapters. It talks about the generic overview of USF, universal payload, configuration, shareable code, security, and then there's a section on the scalable FSP. And it kind of reads on 3 parts that we'd like to potentially evolve with the community. Here is the libraries. Again, each of these FSP consumers sort of do it in their own, consume the FSP in their own way. So let me see if I have a page open here. Yeah. So live or die by my open tabs on Chrome browser here. So again, these APIs include C-based ones. There's Intel FSP2 wrapper package. We have interfaces into the APIs. We've evolved it as part of USF to include this measurement so we can start providing some more provenance and security. We have some guidance on how to actually port your bootloader to an FSP2X. We have some representative Rust-based examples, the core boot driver, and I think I forgot to journal some of the Slim Boot interfaces. So, you know, one aspect of USF that I think would be interesting would be we have kind of all these variants of how to abstract the FSP, maybe come up with some more class-like interfaces and shareable libraries. That's, I think, one opportunity. Of course, the interactions are always important because that reads on your layout of your sort of POL code, and then some potential future capabilities. So that's kind of the touch points in USF on the scalable FSP, but the FSP itself is not subsumed into the USF spec. It's kind of its own kind of animal done by reference right now. But I would argue some of the library, you know, shareable software across the different POLs, how we evolve configuration between bootloaders and FSP are all fair game for the USF spec. And then given we want to align our platform implementations in FSP, it's important to talk about some of the potential future directions of FSP. And to that end, sort of when we started USF, we realized there's kind of this tight coupling between the FSP and the platform code, right? You can say, let's do all these interesting innovations and evolutions of the FSP, but a lot of these POLs that sit on top derive from open source frameworks. So how can we balance sort of some what ifs between the FSP evolution and these bootloaders? And to that end, we, on the Universal Scalable Firmware GitHub, we have that FSP SDK. And in the past, our what ifs always were like an FSP port to a new or an old SoC, and we'd publish it on the web as a binary. But since we're sort of doing this exploration of platforms and FSPs and payloads, sort of take a fake chipset, namely QEMU, and port the FSP to it. I think the closest thing we had in the past was we built a Quark FSP because Quark at the time was open source fully. But then, as folks know, Quark is not the most easily acquired board. It's 32-bit only, single core. So it met the spirit of the what ifs by being open, but it kind of was inflexible from its capabilities. So we ported FSP to QEMU, and then we have branches on what would a 64-bit FSP look like. the SMM work, that if we were to encapsulate some of the SMM infrastructure in FSP, did that work on a branch? Some of the original work on configuring FSP with YAML. And then to support some of these early discussions, the 64-bit and SMM, we even put a draft of the prospective 2.4 on this site. And so the idea here is, since all the bootloaders have to move in tandem with FSP. FSP is really just an interface. The important stuff, the silicon details and such, are not necessarily done in the open, but the interfaces are. And so, since we want to be friendly with the community to evolving their platform code consonant with these interfaces, one of the things wanted to sort of let folks know, as today we kind of are doing a lap through USF and where we're at, what we're thinking is some of these FSP interfaces, potential changes done in the open. And then there was some initial thinking of what could be a future FSP, this thing we call an FSP at reset, even have a prospective variant of that, which introduced a new component called an FSPR and an FSPC for configuration. But again, these were just some what ifs done in the open. And again, it kind of builds on the spirit of even when we did the FSP 1.1, I believe at that time, we published a doc that said, hey, this is a way to build the FSP out of some EDK2 infrastructure code. So although, again, the silicon modules within are not necessarily public, how it works, how it's put together, provides some introspection on that. So, but yeah, definitely we've heard in this forum requests for more open. One of the potential, of course, could be, maybe some of the modules in the FSP could be delivered as binary, source plus binary, or build some subset in the open. Those are business decisions, but having this FSP SDK at least allows a technical discussion around what something might look like. Again, this is not a roadmap Intel meeting. This is just a generic community meeting about stuff in the open here. But that's kind of the intent behind it. And when we have heard requests for open, FSP itself, the business process today is in binary. I'd argue for consistency and provenance tracking, like we mentioned above, being in binary will actually be a boon, but perhaps a subset if it were required ever to be open. This would be a facility for it. And then the other thing that we've heard from some of the earlier meetings here is how to align maybe some of the thinking with other layers with FSP. So I think Ray and others and Guo had some great discussions around UPL, the universal payload, and something like CBOR. So there's been some discussion about, hey, if we do self-describing things like CBOR, would it make sense in lieu of UPD, in lieu of Hobbs? Since Hobbs are both inputs to the UPL and they're both outputs of the FSP today, maybe CBOR might make sense. Perhaps that's something we could explore in our FSP SDK mock, right? Because again, this is just a software construct. That's something that I think we really appreciate some of the community discussion and feedback on that, or whatever that data structure is. If there are any changes based upon some of the ARM input last meeting. Again, these are touch points on the outside. Again, we don't want to, we want to have a nice abstraction on the outside of sort of the silicon component to ease integration. So that's kind of something that we've definitely heard in these meetings and might be a viable evolutionary path to talk about here. And then the other thing I wanted to do today, I'm mindful of folks' time, is sort of, since this is the last of our review topics, again, we had the what is USF, universal payload, the different bootloaders all did a review, configuration, and now that's kind of, if we look at the TOC of the USF spec, I guess I maybe didn't tell a complete truth. Maybe we didn't have breakout sessions on runtime and security, but we kind of hit the high order bits in these sessions so far. One of the things I wanted to just talk about today and share some thinking is how was this all framed in 2022? Had a colleague, David Graurock, who did the original LT TXT. I think he's retired now, but he once told me, asked me, what's the difference between an engineer and an architect? Engineers have deadlines. So if this is a pure jam on architecture, designing things, you could go till 2028. I'd have a fun time with you folks, but want to constrain some of what we're doing if possible. So worked with others on this effort on some postulating some milestones, and really these are not Intel super secret milestones. Since this is a community effort, really this is just what we were thinking and we wanted to share, is try to land some of these 2.4 items, 64-bit, the SMM. One item we haven't surfaced is maybe how we could expose persisting things from FSP. Today there's an NV hob. Can we do a better job that if FSP says I need to save something, tell the bootloader that? That's kind of code for what this NV is here. Sort of land that this quarter. Continue a pace with the breadth of the USF. Now that we have accelerators, discrete graphics, IPUs, DPUs, bringing those folks in such that how they do configuration, how they export telemetry, do updates. Really, we have not just a full stack view to turn on our compute SoC, but really composing firmware that supports the complement of components you'll have in a modern system. Get some more community discussion on that that we can land in Q3. I've talked to the UPL folks. There's definite UPL fixes. Maybe we could drop a .8 in here that tightens up the UPL. So this doesn't imply these are the only points in time we'd punctuate. There could be some a UPL milestone in the middle here that we'd like to bring in a proposal shortly. And then some other kind of FSP, what it might look like for being a more USF friendly. There's this sort of FSPV here. I think we intoned a bit in the earlier deck. What the idea here is, could we have some sort of self-test style validation interfaces? That's something as we evolve would like to bring. Validation is kind of it's kind of not always top of mind on a lot of community efforts, but it's eminently important as we do our host firmware and our XPUs, and it's actually kind of aggregated, because if you have these rich USF stacks where you can change and recompose the different elements, does the ensemble work together? So we've had a history of this one bootloader did it one way, the other bootloader may have omitted a step, and how did they know? That's kind of the thinking behind having these sort of self-test interfaces. This FSP reset, kind of that's code for, could we have a more just drop in, maybe normalize our interfaces so we don't have that disparity between dispatch and API mode. We have a more consistent bootloader programmer interface. And then ACPI, this is one that I can explain the intent, but some of the folks leading this are not ready to kind of share some of the thoughts. Is a lot of these bootloaders all do ACPI, but there's sometimes some tacit framework specific artifacts in the implementation. So generalize how ASL is constructed to be shareable across bootloaders. That's kind of lateral sharing. And then maybe some horizontal sharing where if there's some SOC specific details of the namespace, maybe FSP can provide that. Not with an eye toward, trying to, hide things, but maybe just ease the workflow of building platforms. So I think this was kind of the last slide. And really what, again, I wanted to do was sort of try to tie off the promise we made that these first meetings would be summaries of the USF stack. What is USF? And then iterate your way down. Payloads, platforms, configuration, and then the scalable FSP. And then as part of tying that off, framing some milestones we thought would be interesting to work with the community, since this USF spec is owned. FSP is very important, so want to provide visibility into some things we're thinking, and maybe sort of get to a 1.0 by end of year. And that was the last content slide I have, so I think I'll pause here and questions, comments. You guys are all on mute, so I probably can't hear the snoring. So.
No, the great summary, Vincent. Thank you so much. Awesome.
Yeah, this was great.
Okay, so yeah, I think that's what I had, and probably the next meeting probably should do some agenda bashing here, Mickey, would be what might we queue up next? I don't know if we have if the UPL, some of the thinking on the UPL GUO we'll be ready for perhaps a deeper dive into security. I can solicit that, since that's a timely topic, but
yeah, now we are working on the security part for the UPL. Once we have some thing can be discussed, maybe, yeah, we can add into, we can talk in this meeting.
Okay, so maybe we can work offline, sort of see if there's anything at the sort of the readiness level that.
Yeah.
Or we can also reach out to some of the former presentations, see if there's updates. Like, since the ARM presentation they did, they brought to the core boot working group and liaised it there. Maybe we can see if there's any opportunity to double back on that or some other topic, but okay.
Yeah.
And yeah, I just want to join people in the engineering deadline excitement versus architecture unboundedness. Balance the two in this incredible journey we make here. Rock will be smiling wherever he's fly fishing right now in Oregon. So
Yes.
and I'm quoting him. He might charge me a fee though for quoting him, so maybe I shouldn't quote him too much. Some copyright.
So I put down a call for topics and for future topics, and also that security.
Sounds good.
So who is the person to contact about security?
Yeah, I think Jiwon Yao is probably, he led the initial work stream on this, and I actually talked to him last week. And in fact, the UEFI, one of their Bright Talks were saying, could you do something else? I'd hate to do a talk there and not do a talk here, so let's see if we can marshal Jiwon Yao for that one.
Okay, that would be great.
And that will be the after the evening time slot, right?
Well, that's right. He's in Shanghai. That's correct. Good point, Sarathi. Yeah. Or it's not Sarathi. It's Fadi. I'm really losing it. Yeah.
No offense.
I feel a pain in my neck. You must have taken that voodoo doll and put a pin in. Yeah. It's been a long week. Yeah. Sorry, Fadi.
Okay, so you're gonna see if you can get him to do that?
Yeah, I will.
Okay.
Because again, I think it'd be precipitous us to talk in the UEFI forum that can't spell USF so well, versus sort of folks who are deep in it. We should liaise it here first. So yeah, I'll work that.
Okay. Well, that's great. Does anybody have anything else that they would like to bring up or discuss or talk about? And if not, I'm going to stop recording.